You are designing a globally distributed web application that must provide low-latency access to users worldwide. The application will use both static and dynamic content and requires a solution for dynamic failover between regions in case of a regional failure. Additionally, the database backend must replicate data between regions for consistency. A. Use CloudFront for static content, Global Accelerator for dynamic content, and Aurora Global Database for backend replication. B. Use Route 53 with geolocation routing, S3 for static content, and RDS multi-AZ for the database. C. Use CloudFront for static content, ALB for dynamic content, and DynamoDB global tables for backend replication. D. Use Route 53 with latency-based routing, CloudFront for static content, and RDS read replicas for database replication. Correct answer, A. Use CloudFront for static content, Global Accelerator for dynamic content, and Aurora Global Database for backend replication. Explanation: CloudFront caches static content at edge locations, reducing latency for users worldwide. Global Accelerator ensures low latency routing for dynamic content and provides automatic failover between regions. Aurora Global Database replicates data between regions with minimal latency, ensuring consistency in a globally distributed application. Why not other options? Option B, Route 53 geolocation routing can direct traffic to the nearest region but doesn't handle dynamic failover effectively. RDS multi-AZ only provides failover within a single region. Option C, ALB doesn't provide low latency routing for global users. DynamoDB Global Tables is suitable for NoSQL, but this scenario requires relational database consistency. Option D, latency-based routing is useful, but RDS read replicas are read-only and cannot serve as a full failover solution. Your company needs to process large volumes of incoming sensor data in real time. The pipeline must scale automatically and store processed data for analytics. You want to minimize infrastructure management and ensure cost efficiency. A. Use EC2 instances with autoscaling, SQS for message queuing, and RDS MySQL for data storage. B. Use kinesis data streams for ingestion, AWS Lambda for processing, and DynamoDB for storage. C. Use Elastic Beanstalk for application management, S3 for storage, and EMR for processing. D. Use kinesis data streams for ingestion, AWS Glue for processing, and Redshift for storage. Correct answer, B. Use kinesis data streams for ingestion, AWS Lambda for processing, and DynamoDB for storage. Explanation: Kinesis data streams enables real-time ingestion and streaming of large amounts of data. AWS Lambda provides a serverless and cost-efficient way to process incoming data in real time. DynamoDB is ideal for storing processed data because it is scalable, fully managed, and integrates seamlessly with serverless architectures. Why not other options? Option A, EC2 requires infrastructure management and isn't cost-efficient for a serverless approach. RDS MySQL doesn't handle high-frequency writes as effectively as DynamoDB. Option C, Elastic Beanstalk is not serverless and introduces overhead. EMR is suited for batch processing, not real-time data streams. Option D, AWS Glue is a serverless ETL tool but adds latency compared to Lambda. Redshift is optimal for analytics, but it is less suited for real-time data ingestion. A financial services company runs batch jobs that process sensitive data every night. These jobs can take several hours, but they must be completed before 6 a.m. Data security is critical, and the solution should minimize costs. A. Use EC2 on-demand instances with EBS encryption for compute and storage. B. Use EC2 spot instances with EBS encryption and auto-scaling to manage job execution. C. Use AWS batch with spot instances for compute and S3 for storage. D. Use Lambda functions for compute and S3 with server-side encryption for storage. Correct answer, C. Use AWS batch with spot instances for compute and S3 for storage. Explanation: AWS batch simplifies batch job scheduling and execution, managing spot instances to minimize costs. S3 with encryption ensures secure and cost-effective storage for sensitive data. Spot instances significantly reduce costs, while AWS batch retries jobs in case of spot interruptions. Why not other options? Option A, on-demand instances are reliable, but far more expensive than spot instances. Option B, while auto-scaling helps, manually managing spot instances adds complexity compared to AWS batch. Option D, Lambda has execution time limits, 15 minutes, making it unsuitable for long-running batch jobs. You need to expose a REST API to external customers. The API should support millions of requests per day and integrate with an existing backend running on EC2 instances. Security is a top priority, and you need to restrict access to authorized clients only. A. Use API gateway with IAM-based authentication and direct integration with EC2. B. Use API gateway with Lambda authorizers and a private integration to EC2. C. Use Elastic Load Balancer in front of EC2 and WAF for security. D. Use API gateway with Cognito user pools and an integration with EC2 autoscaling. Correct answer. B. Use API gateway with Lambda authorizers and a private integration to EC2. Explanation: API gateway provides a secure and scalable API frontend. Lambda authorizers add custom authentication logic to validate incoming requests. A private integration ensures that traffic between API gateway and EC2 remains within a VPC. Why not other options? Option A. IAM-based authentication is suitable for internal users but not practical for external clients. Option C. ELB provides load balancing but lacks API management capabilities. WAF improves security but doesn't handle authentication. Option D. Cognito is suitable for user authentication, but Lambda authorizers provide more flexibility for client-level validation. You are building a multi-region application that requires secure file transfers between clients and S3 buckets in different regions. File uploads should be authenticated, encrypted, and routed to the nearest AWS region for lower latency. A. Use S3 transfer acceleration with IAM roles for authentication and SAA C03 for encryption. B. Use CloudFront with S3 as the origin and enable HTTPS for encryption. C. Use an Elastic Load Balancer with EC2 instances to proxy uploads to regional S3 buckets. D. Use Route 53 with geolocation routing to direct clients to the nearest S3 bucket. Correct answer: A. Use S3 transfer acceleration with IAM roles for authentication and SAA C03 for encryption. Explanation: S3 transfer acceleration improves upload performance by routing data through AWS edge locations to the closest S3 bucket. IAM roles authenticate access securely. SAA C03 ensures server-side encryption for data at rest. Why not other options? Option B. CloudFront improves content delivery but is not designed for direct uploads to S3. Option C. Using an Elastic Load Balancer adds unnecessary complexity and cost compared to S3 transfer acceleration. Option D. Route 53 geolocation routing helps direct traffic but doesn't handle secure uploads or optimize performance. You are designing a stateful application that requires a relational database backend. The application must run in multiple availability zones, AZs, to ensure high availability and automatic failover in case of an AZ failure. A. Use RDS multi-AZ with a read replica for scaling. B. Use Aurora with multi-AZ deployment and enable global database replication. C. Use DynamoDB with global tables for state management. D. Use EC2 instances with MySQL replication configured manually. Correct answer: B. Use Aurora with multi-AZ deployment and enable global database replication. Explanation: Aurora provides automatic multi-AZ failover and high availability. Aurora's global database replication ensures data consistency across regions. Why not other options? Option A. RDS multi-AZ provides failover but lacks the advanced performance and scaling of Aurora. Option C. DynamoDB is a NoSQL database and unsuitable for relational workloads. Option D. Manually managing MySQL replication on EC2 is operationally intensive and error-prone. You need to build a real-time log analytics solution for your application. Logs should be ingested, processed in near real time, and stored for long-term analysis. The solution should minimize operational overhead and support querying of data. A. Use Kinesis data streams for ingestion, Lambda for processing, and S3 for storage. B. Use CloudWatch logs for ingestion, Athena for querying, and Glacier for storage. C. Use OpenSearch, formerly Elasticsearch, for ingestion and querying, and S3 for archival storage. D. Use Kinesis Firehose for ingestion, Redshift for querying, and S3 for storage. Correct answer, C. Use OpenSearch, formerly Elasticsearch, for ingestion and querying, and S3 for archival storage. Explanation: OpenSearch is optimized for indexing and querying log data in real time. S3 provides cost-effective archival storage. Why not other options? Option A, Lambda is not designed for querying large datasets. Option B, CloudWatch logs and Athena work for batch analytics, not real-time use cases. Option D, Redshift is ideal for analytics, but not designed for real-time log processing. You manage multiple AWS accounts. Developers in account A need to access specific S3 buckets in account B. Access should be restricted to only the necessary buckets and actions. A. Use a bucket policy in account B to allow access from IAM users in account A. B. Use IAM roles in account B and allow developers in account A to assume the roles. C. Enable cross-account access using AWS Organization Service Control Policies, SCPs. D. Create IAM users in account B and share their credentials with developers in account A. Correct answer, B. Use IAM roles in account B and allow developers in account A to assume the roles. Explanation: IAM roles allow secure, temporary cross-account access while adhering to the principle of least privilege. Why not other options? Option A, bucket policies don't provide granular, temporary access like IAM roles. Option C, SCPs control account-level permissions but don't grant specific bucket access. Option D, sharing credentials violates security best practices. A team is training a machine learning model that requires significant compute power. The workload runs for several hours and uses training data stored in S3. The team wants to minimize costs and simplify infrastructure management. A. Use EC2 spot instances with EBS for storage and training scripts. B. Use SageMaker for training and S3 for input-output data. C. Use AWS Batch with spot instances for training and S3 for storage. D. Use Lambda functions for training and DynamoDB for intermediate storage. Correct answer: B. Use SageMaker for training and S3 for input-output data. Explanation: SageMaker simplifies machine learning workflows by managing training infrastructure and integrating with S3 for data storage. SageMaker also optimizes costs with managed spot training instances. Why not other options? Option A, spot instances are cost-effective but require manual management of training scripts and infrastructure. Option C, AWS Batch is not optimized for ML workflows compared to SageMaker. Option D, Lambda is not suitable for long-running ML training jobs due to execution time limits. You need to archive large amounts of data to meet compliance requirements. Data must be stored securely for 7 years, and access frequency is low. Cost minimization is a priority. A. Store data in S3 standard with server-side encryption. B. Store data in S3 intelligent tiering with object locks enabled. C. Store data in S3 Glacier Deep Archive with a vault lock policy. D. Store data in EFS with lifecycle policies to transition files to lower-cost storage. Correct answer: C. Store data in S3 Glacier Deep Archive with a vault lock policy. Explanation: S3 Glacier Deep Archive is the most cost-effective storage class for long-term archival with infrequent access. A vault lock policy ensures data immutability for compliance. Why not other options? Option A, S3 standard is too expensive for archival use. Option B, intelligent tiering is not as cost-effective as Glacier Deep Archive for archival workloads. Option D, EFS is a file system, not optimized for long-term archival.